All right, so it says create a table of values and then sketch a graph of the function. Determine the vertex, the axis of symmetry, the direction of opening, the maximum or minimum value, the domain and range, and the x-intercepts and y-intercept. So basically everything we've learned. So what we're going to do first is create our table of values. So let's do that. So our x and y, and I'm going to go from -3 to 3. So -3, -2, -1, 0, 1, 2, 3. So what we're going to do is just sub our values for x into this equation. So y is equal to -3 squared minus 2 times -3 minus 3. That's going to be our first value. And what I got when I put that in my calculator is 12. Now you might have noticed this is not in vertex form. It actually looks different, right? It's actually in standard form, but it doesn't matter when we're making a table of values. All we're doing is subbing in the x values and figuring it out. So if we sub in -2 into both x values, we're going to get 5. If we sub in -1, we're going to get 0. If we sub in 0, we're going to get -3. If we sub in 1, we're going to get -4. If we sub in 2, we're going to get -3. And if we sub in 3, we're going to get 0. So let's actually plot this. So the first point is going to be -3, 12. And that's actually off of my chart. So I'm not going to worry about it. The next point is -2, 5. So -2, 5 I can do, no problem. -1, 0. Good. 0, -3. That's there. 1, -4 is there. 2, -3 is there. And the next point is 3, 0. And if I kept on going, I would probably get something up here. But I'm not going to bother because this is enough for me to see that this is a parabola. That isn't too bad. So there, we've made a table of values and we've sketched it. Okay, we're done that. Good. Determine the vertex and all this stuff. So to do this, we're going to need to get this into the vertex formula. And that takes a little bit of math, actually. What we're going to do is we're going to use this handy little formula that says the x value of the vertex is going to be equal to -b over 2a. Now this will make sense when I show you this. So the standard form is like this. It's equal, y is equal to ax squared plus bx plus c. That's the standard form. Our form, the vertex form, is y is equal to ax minus p squared plus q. So as you can see, there's two letters in common with the standard and the vertex form. But we really need to get our standard form into the vertex form. So what we're going to do is use this formula to solve for the x value of the vertex. Because remember in our previous example, if you know what the vertex points are, we can pretty much just solve this right away. So let's do that. So we're going to say x is equal to, and we're going to look at the b value of our standard form. So the b value, as you can see, is this -2. So we're going to have minus -2 divided by 2 times the a value from the standard form. And a is just 1. So 2 times 1. So we're going to have 2 over 2, which is just equal to 1. So our x value of the vertex is just equal to 1, which makes sense from our sketch. Now to find the y value of the vertex, we're going to sub it back into the original equation. Okay, so we're going to sub this 1 in for all the x values. Now we already did that here. So if we write y is equal to 1 squared minus 2 times 1 minus 3, we get that is equal to -4, which also makes sense because there's our vertex. So our vertex is at 1, -4. Now that we have the vertex, we can actually just sub that back into the vertex formula. So to find the vertex formula, remember what we did last time? We did this. we said y is equal to a x minus p squared plus q. We're going to sub in the vertex, which is 1, negative 4. So we're going to say y is equal to a times x minus 1 squared minus 4, because we sub in the x value for p and the y value for q. So all that we need to find now is a. And actually we already have it, because this is our formula here. Y is equal to x squared minus 2x minus 3. And when we looked here at our standard formula, we noticed that both of these had an a. So actually the number that's in front of x squared is the same thing as a. So the number that's in front of x squared here is just a little 1. So we can just say a is equal to 1, and then we have y is equal to 1. We don't even write the 1, right? We just write x minus 1 squared minus 4. And that's our vertex formula. So let's take a look and see what we've done so far. So we found the vertex, and we found the vertex formula, which is awesome, because we need that for the rest of this stuff. So the axis of symmetry we can look at, and we know that the axis of symmetry is just the line that runs right through the vertex. So the axis of symmetry is just, I'll write down here, axis of symmetry is just x is equal to 1. And actually it's always just the x value of the vertex, right? And what else do we need to find? The direction of opening. Okay, that one's easy. Okay, it opens up. The maximum or minimum value, all that is saying, okay, if it opens upward, then it has a minimum value of y is equal to negative 4. Okay, if it opened the other way, we'd say it has a maximum value. If it opened up like this, we'd say y has a maximum value of negative 4. Those ones are pretty simple to do. The domain and range. So let's try those ones. What I'm going to do is actually erase this stuff, and then we'll have some space to do the domain and range and the x-intercepts and y-intercepts. So we found the vertex formula was y is equal to x minus 1 squared minus 4. So when we're looking at the domain and range, we can just kind of look at our graph and look at our formulas here and see that, okay, well, the domain is always the same, right? So x is contained in real numbers. Now the range, we look at the y values. So the y, the lowest point it's going to be is negative 4. So y is going to be greater than or equal to negative 4. Y is contained in real numbers. Now, the x-intercept and the y-intercept are a little bit more tricky. So let's try the, up here, let's do the x-intercept. So the x-intercept. So to find that, we need to set y equal to 0. And this makes sense because when we look at our graph, any place that the line crosses the x-axis, our y value is going to equal 0. So all we do is take our formula, set y equal to 0, and solve. So we're going to say 0 is equal to x minus 1 squared minus 4. So we're going to move the 4 to the other side. So 4 is equal to x minus 1 squared. So obviously we square root it to get rid of the squared. So we have the square root of 4 is equal to x minus 1. Now, something we need to talk about is this here. So before in the course, whenever we square rooted anything, we would just say, okay, well, that's equal to 2. But the question I have for you is, we know that 2 squared is equal to 4, right? What about negative 2 squared? That's equal to 4 as well. So when I square root 4, right, if I square root either of these, we know that this one's equal to 2, but we know that this one's equal to negative 2. Right? So that means that every time we square root something, we actually have a positive and a negative answer. So we're going to have the square root of 4 is going to be plus or minus 2 is equal to x minus 1. We move the 1 over to the other side. So we have plus or minus 2 plus 1 is equal to x. So we have 2 plus 1 is equal to x, and we have negative 2 plus 1 is equal to x. So then for x values, we have x is equal to 3, and x is equal to negative 1. And this is very important. So these would be actually our x-intercepts. It'd be 3, 0, and negative 1, 0, right? Because we set y equal to 0. And those would be our two x-intercepts. And if you look at our graph, we're right. So it goes through 3, 0 and through negative 1, 0, if I could draw a parabola correctly. Now, for the y-intercept, all we need to do is set x equal to 0. Because when it goes through the y line, our x value is going to be equal to 0. So we just say y is equal to 0 minus 1 squared minus 4. So y is equal to negative 1 squared is just 1 minus 4, which is just equal to negative 3. So our y-intercept then is just going to be 0, negative 3. So we found everything in this question. It was a fair amount of work, but now we know how to do quite a bit more. And actually a bunch of this was review stuff as well from our previous lessons.